Okay. So guys, some announcement first. Okay. To make sure the microphone works well. All right. All right. Number one, about the projects. It's released. So make sure you find at least one partner for your team. It's required for the project. It's a lot of work, so please make sure you start early. I will release lab number 5 next Wednesday. Between now and next Wednesday, I would suggest trying to make progress on your projects. And for your lab test, it will be November 28th. I'll give you some study guide early next week so you'll know exactly what to expect. Okay? Okay, that's about what I want to say about announcement. Okay? Now, let's now go back to the topics about subcontracting. Let me just bring you to, again, the logical background that we just reviewed last time. Let's go over that very quickly. Okay, you just have to understand the definition here. Okay? If we have two preconditions, P1 and P2, we define that to say one precondition requires less than the other one. Let's say if you say P2 requires less than P1, that means P2 can be more tolerant on the input values. Logically speaking, you can say all the satisfying input values for P2 will be larger than P1, right? That's what we said. And what you can simply use implication to check. You will simply got P1 implies P2, right? That's something we discussed already. I'll revisit the example which I got wrong last time about the smartphone. Okay, I'll just make sure everything is corrected. That's about a precondition. Now, let's switch the context to postconditions. If you have two postconditions or invariants, Q1 and Q2, right? Usually when we talk about postcondition, we're talking about ensuring some service to be provided to the clients. So when we say Q2 ensures more service than Q1, okay? That simply means you can actually have stricter criteria on the output values from Q2 than Q1. Logically speaking, you simply got Q1 satisfying value for the output is less than or equal to the satisfying value for Q1. Okay? So there's a very common misconception over here. You might think, when I say Q2 ensures more, you might think the corresponding set for Q2 will be larger than Q1. No, it's not. It's the opposite. It simply means it's stricter. So to check this, logically, you get Q2 implies Q1. Okay, good. Let's go back to our example here. Over here. So we talk about substitutability. If you have a phone user over here, and then you declare something, an attributes my phone of type smartphone, right? And then for smartphone, you also got iPhone 6s Plus, right? We got subclass and we got superclass. Now, the question is, how should we interpret the require and ensure for this parent class versus the require and ensure for the subclass, right? That's the issue we are talking about. Basically, here's the principle. This is the principle you have to know. In summary, in the subclass, you want to make sure for substitutability, in order for substitutability, so there are two criteria over here. Number one, you want to make sure you require less. And then over here, you want to say ensure more. Okay? In order to justify informally, think about what if you don't satisfy these criteria. Let's say, if the descendant class, the iPhone 6s Plus, happen to require more, what does that mean? That means what you used to really expect for the input value on the smartphone, they cannot be satisfied anymore by the iPhone 6s Plus. That would be quite a shock to the clients. So that means you got to require less. We'll see example. And also for ensure over here, what if the functionality you're trying to implement actually ensure less from the iPhone 6s Plus? That means whatever surface you're expecting from the superclass, now they cannot just be ensured as much in the subclass like iPhone 6s Plus. So that means that's also not good. So the opposite should be the case. So that means it require less or ensure more. But let's see more concrete example. Okay, this is something we discussed last time, but I did make a mistake last time. Let's revisit very quickly. Okay, let's first of all consider the preconditions. So I would like you to look at the precondition first. So the precondition at the parent class is this, and the precondition in the descendant class is this. Okay? So now the correct relation should be, first of all, we know that alpha does not imply gamma. Okay? Let's make sure we agree on this. Okay? Whenever you want to check for implication, if you don't think implication will hold, you have to give a counter example, right? You want to give a counter example which will show you that the implication simply doesn't hold. Okay, let's see why. Okay, I'll give you one example here. So here I'm simply saying that if alpha can be true, it doesn't necessarily always imply gamma is true. Okay? Can anybody give me just one counter example? Just one. 0.12, for example, right? Let's say let me say battery level over here. Let me just say this is just X, just make it easier for me to write. If I say X is simply equal to 0.12, 12%, let's say. Now, is it going to satisfy alpha? Yes. It is. So that means alpha is going to be true because 0.12 larger than or equal to 0.1. That's true. What about beta? Is it going to satisfy that? Well, no, right? Because apparently 0.12 is not larger than or equal to 0.15. So that will be false. In this case, if you got alpha implies beta, that will simply give you true implies false, which will be false. So that means implication doesn't always hold. That's how we prove that it is not the case. Yeah? When I say gamma, I really... Oh, yes. Thank you. Thanks so much. I like that. Yes. And then over here, I also meant gamma. Yes, thank you. Okay, that's good. Thanks. Okay, so now to really make it complete, you can think about what we really have is gamma actually implies alpha. This is a correct relation to expect. Especially, let's think about this. If I draw the set of values for gamma, it's going to be every value that's larger than or equal to this value here. For example, 0.15, 0.16, 0.17, and etc. Right? So now, what about the set for alpha? It's going to be strictly larger in this case, right? That means we have this set over here that's for alpha. One example could be, let's say over here, 0.1. So 0.1 is not really included in the set for gamma, right? And also 0.11, 0.12, 0.13, and 0.14. So these are the values that's only included in alpha but not gamma. Okay, that's just one example of showing you how you can reason about it. So now, once we can figure out a logical relation between these two preconditions, what we got to think about is, does this make sense in terms of design? Well, are we really requiring less in the descending class in this case? Not really, right? Because if require less, that means alpha implies gamma must be true, but it's not the case. So we are not really requiring less. Actually, in this case, we are actually requiring more. Requiring more. This is why the set for gamma is strictly smaller, because the criteria is actually higher. Okay? Yes?
So what do you mean by requiring more? Like more inputs, more kind of restriction?
Requiring more means you are trying to put more restriction on the input. That's correct. Yeah. Also ensuring more also as well. Yeah.
So another thing is like
Stricter. Stricter simply means you're being more strict on what can be passed on the input value, right? If you're being more tolerant, that means you're more, just more, you can accept more input values when you try to execute a feature. Okay? Okay, guys, any question about this? So since we know it is not the case that alpha implies gamma, so this is not a perfect design. This is not an appropriate design. Think intuitively. For the smartphone, I expect they'll get reminders feature to work if the battery level is at least 10%, right? So now let's say I got 12%. That's what I can expect from a smartphone in general. However, when I substitute my smartphone by an iPhone 6s Plus, which actually requires more on the input value, if 12% is not going to satisfy the 15%, that means what I used to expect to work is now not going to work, just because I got stricter precondition. Questions? We're okay, right? Good. So that's a correction I'd like to make from last time. Now, if you look at the second version over there, okay, let's see if that one's going to work. Again, let's look at the alpha over here and gamma over here. Do you think this would be appropriate design in this case? So now, if whether or not this will be appropriate, so basically ask yourself, is this appropriate design of precondition? You simply ask, is it the case that alpha implies gamma? Is it the case? Right. Basically, whatever that is true for larger than or equal to 10%, it should be for sure larger than or equal to 5%. Right? So this is okay. Okay, the same argument applies. Okay, that's about the precondition. Okay, so this indeed requires less. Okay, let's have a look at the post-condition. Okay, if we go back to this version over here, let's look at the post-condition. Let's say beta over here, the green, beta here, and we have delta here. Okay, let's read it out together. Beta is saying all the events in the reminder should be happening just today. That's what we expect from that's what we expect to be returned as a surface by the get reminders in this parent class. Now, if I say I can substitute whatever you expect for the smartphone by a descending class surface as follows. I say every event is going to be happening either today or tomorrow. Intuitively, you might think, oh, since I can include all the events, not only today, but also tomorrow, so I'm having more events to be included. So that should be ensuring more, right? No, that's the common misconception. That's exactly not, okay? You can think about over here, if you think about the beta over here, beta is basically all the events happening today. It could be today at 1 a.m., today at 2 a.m., and today at 3 p.m., etc. Right? However, on the other hand, you can think about the delta over here. Is it going to be a bigger set or smaller set? Bigger set, right? If it's going to be a bigger set over here, let's say this is delta. Give me one example that's in, sorry, not delta. Give me one example that's in delta but not in beta. That's it. Well, basically just any event that's not today but tomorrow, right? So it can be tomorrow, maybe it can be tomorrow, but it's actually 2 a.m. tomorrow after the midnight of today already, right? Okay? So basically all you have to make sure is E happening today, you can think about it's more like a P. Think of it. And E happening today or tomorrow is more like P or Q, right? Do we have P implies P or Q? Do we or do we not? We'll put it another way. Yeah, we do actually, right? On the other hand, when I say P or Q implies P, is it the case? It's not, right? This is not the case, so this is not really ensuring more. Okay? You can think about, let me just annotate a little bit more carefully. You can think about P or Q is exactly what delta is about. Okay? This is really delta. And then P over here is just happening today, so that's beta. So we know that delta, which is the post condition in the subclass, is not really implying or ensuring more than the beta post condition in the parent class. So this is not appropriate design. So what would be an example for appropriate design? Which means you have to make sure whatever you return as the post condition there must be logically stricter. Okay? Let's give one example here. If you look at that over here, let's see it again. Let's say here, the blue one, this one versus this one. Do you think it is not ensuring more? Well, beta basically can be every event happening today between starting from 12 a.m. until 11:59 p.m. But now the delta over there trying to make sure it just give you a subset, which is between 9 a.m. and 5 p.m. Right? Let's draw the diagram over here. In this case, we do have delta over here. Delta over here implies beta. We do have it. Okay, if you can think about, you can see that beta is basically like this. You can think about beta basically is going to be all the events happening today, right? You can be, again, it can be 1 a.m., 2 a.m., 3 a.m., and etc., right, until the 11:59 p.m. And what will be included only in delta is like this. You can think about delta is just a subset of that. It's going to be between 9 a.m. and 5 p.m. So starting from 9 a.m. until 5 p.m. So just a subset. That is why delta over here is logically stronger. Okay, so that's why you got this implication hold. Okay. Guys, are we okay for this? So these are just examples to show you. But when you are given new example to check, all you have to make sure is delta implies beta. You want to judge to see if that's the case. Okay, that's all you got to decide. Any questions about this? Okay, if no question, I just have a few more slides to show you a few more logical properties to talk about, and we are done with subcontracting. And then we'll move on to a new design pattern. Okay. Okay, let's go back to the slides. Okay, so this part we talk about, and you can go over the two versions with basically the same description as I said on the iPad. You can go over them. Okay, so now let's talk about how you can apply this programmatically in iPhone. Okay, we talk about descending classes versus this ancestor classes. So now, whenever you have to declare some new precondition in the subclass, you have to say require else rather than just require. And if you want to declare for new postcondition in the subclass, you have to say ensure then. Okay, there's a reason for this this extra keyword. Can you remember? Do we say or else or and else? Or else, right? And do we say and then or then? And then. That's exactly why they actually chose this keyword. Simply because whatever you put in the precondition, the subclasses, they will be ORed, they'll be disjoined together with the precondition inherited from the parent class. Okay, let's see how do you apply that. So now we talk about whatever you put in the precondition for the subclass and the superclass, how will they be checked at the runtime? Okay, this is the formula, but I'll try to explain to you the rationale behind. Let's say this. Let's say from the parent class, you got original precondition that you have, just require. And in the subclass, you just say another one, say require else, the new precondition, right? We got two preconditions over there. But at the runtime, what do we check? We actually check the disjunction between the two. Okay? Let me give you one example here. Let's say over here. Let's go back to this particular example here. I'll just put over here at runtime. Okay, let's say if currently the dynamic type is iPhone 6s Plus, and I try to say get reminders. So what would be the precondition over here to check? It would be gamma, which is the new precondition. Oh, you know what? Let me put in the order corresponding to the slides. Alpha is inherited to this class. That's a precondition from the superclass. That'll be alpha, and also we got this new precondition in the subclass, which is gamma. And the way we check them would be just or. So alpha or gamma. That's what we check. So we check to see either the battery level is larger than or equal to 10%, or the battery level is larger than or equal to 5%. That's what they will be checked. But what's the rationale behind? Why are we using disjunction rather than conjunction? There's a reason behind. Okay? Let's say this intuitively. Here's, and I'll show you the logical rule. If the precondition for the superclass is already satisfied, by substitutability, we shouldn't worry about the precondition for the subclass anymore, right? Because whatever we expect from the superclass, if we satisfy the precondition already, we should be able to pass the value as input to the feature call. There should be no problem, okay? Logically speaking, how can we do that? Let's see that over here. So clients able to satisfy the original precondition from the parent class will not be shocked, which means whatever they used to work on the smartphone level, we shouldn't be shocked if we suddenly got a stronger precondition. Logically speaking, how can we express this? Okay, so let me check your memory from 1019. Okay, easy one. Okay, so basically we talk about the parents require. Whatever that's declared for the parents, and also we got the child require. Get precondition. Now, since we put or over here, right? That's what we check at the runtime. Question for you. If I know this part is already true, which means I already satisfy whatever the precondition is for the parent class, what would be the overall result? True. Exactly. So this one, it really doesn't really matter. It would just be equivalent to true. That is why they use or. Because as long as you can satisfy the original precondition that is declared at the superclass by substitutability, it should just be fine. You are not obliged to also satisfy the child require. So that means you should never try to strengthen the precondition in the child level. It simply has no effects at the runtime. Okay? So you will see that over here. So you see true or precondition at the child level will be just true. You should be satisfied. That's why they choose disjunction. Okay? So a precondition will not occur as long as you're able to satisfy the precondition at the parent level. Symmetrically, if you think about why they will actually use this and then for the postcondition, the same symmetric reason. If I have the original postcondition and the new postcondition, let's say this. I'll show you. Oh, over here. Let's go back here. Again, we have this postcondition over here, beta, and this postcondition over here, delta. At the runtime, what we check will be beta and delta. That's what we'll check. Again, let's get some intuition over here. If it's already sure that I cannot generate any, if there's any event in the reminder, okay, according to this, according to beta over here, every event must be happening today. If I include any event that does not happen today, let's say either yesterday or tomorrow, that means I already violate the postcondition at the parent level. In that case, it doesn't really matter if you can satisfy the new postcondition at the child level or not. Doesn't matter anymore. Okay? So that means if this part is already violated, it doesn't matter about delta anymore. Okay? It will just be violated overall. Okay? So now, if you look back here, if I do a similar analysis over here, we have the parents ensure. And we do the end, child ensure. Okay, similar argument here. If I already know I violate whatever expected surface it is for the parent level for postcondition, does it really matter if I satisfy the child ensure or not? It doesn't really matter, right? Because substitutability, so that will just be false. That's why they're using conjunction there. Okay? Okay, if you go back there, that's exactly, so failing to gain the original postcondition will be reported as an issue. So that means if you got false and new postcondition, it should be false. Right? Okay. Any question about this? About the why we're using require else and ensure then? So far we talked about two issues over here. When you talk about design, you want to make sure whatever contract you have in the descendant class require less and ensure more, right? That's why we check the implication relation and try to give counter example to prove it. Yeah, and then at the runtime, you have to know what kind of logical conjunction or disjunction are being placed in order to combine the two together to do the runtime checks. So these are the two things we talk about. Questions? So remember, in Java, we don't really have a require and ensure. We don't have contracts. So this is, of course, only in iPhone simply because we support contracts in iPhone. But the idea about whether you should really conjoin or destroy the contracts from the parent and child level is more just about theory. Just iPhone implements that. Yeah. But I would say focus more on the concept over here. Okay? Okay? Yeah.
This is slightly unrelated, but command pattern, say that the execute method of a command uses a feature of your system that has preconditions. Since you can't strengthen the preconditions for any of the concrete commands, the effective commands, how would you communicate the preconditions of what you're using from the system to clients of the command?
Okay, this is very specific to your project or your lab 4. I'll just talk about this in a little bit more general sense, okay? But it's for specific question, we can talk about it after class, okay? Let me just mention this. Let's say for your lab number 4, I presume you got in a model cluster a command class that is deferred. And also, the execute feature should be deferred as well, right? And let's say we have a class called maybe set number, where the execute feature over here is plus, okay? That's what we have. Let's say if you happen to have, let's say over here, if you have no precondition for the execute over here, however, you're trying to strengthen the precondition in the execute feature over here. You say require over here. For example, you can say require the value that you're trying to put is less than or equal to 4 and larger than or equal to 1, let's say. Okay? Now, let's try to apply our knowledge from the previous lesson. Okay? So let me just say it again. So we got command as a superclass. We got set number as the descendant class. And for the execute at this level here, we have no precondition. So it's as if we got true over here. Simply no precondition. Okay? So it's as if we said something like this. We say require true over here. And then let's say for this particular set number feature, class over here, I say execute, and then you say require, the value should be between 1 and 4. Okay? Let's just talk about this sign over here. If you think about the two preconditions over here, one is about true, the other one is about 1 is less than or equal to value and less than or equal to 4, right? Is this considered as a good design, as we said? Because we're requiring more in the descendant class, right? Okay, in this case, first of all, let me say that this is not a good design. Yeah, because you're actually requiring more, not less. First of all, requiring more simply means that's right. Requiring more, that means you're putting more restriction on the input value. As we said, that violates the principle for substitutability, right? Now, that's question number 1. It's not a good design, and that's how we judge that, right? The question number 2 is, even if you put it, is it going to, oh, I forgot one thing here. I should say require else. Okay, that's what I meant to say, okay? Now, number 2, is this going to work at the runtime as you might have expected? Which means for this particular set number object, it's going to check to see if the value is between 1 and 4. It's always true, right? If you think it logically, okay? Now, number 2, I'll put it number 2 here. Number 2 is actually even more important. Number 2, I'm going to put it here. At the runtime, what you will check is the following. True, which is from over here, or 1 less than or equal to value, and less than or equal to 4, which will be just true. So it's not going to actually do anything. Okay, so that's actually something you have to be aware of. Okay, so what does that mean? That means for this particular precondition, if you think it's really necessary, you may want to move it to the parent level for this particular one. Okay, but for you a specific question, maybe we can deal with that maybe after the class. Okay, guys, are we okay? Yeah. Second point, sure. The second point, okay, the first point is more about statically, is this a good design? You just try to do some logical proof to see if this precondition over here implies this precondition over here. It's not. So that's not a good design, number 1. Number 2, is this particular stronger or stricter postcondition, is this particular stricter precondition going to work at the runtime? The answer is no. The reason is, at the runtime, as we learned, we're going to combine the preconditions from the superclass and the subclass using disjunction. Given that we didn't specify any precondition in the superclass, it's as if we say true. So true or anything would just be true. So this precondition over here, it has no effects really at the runtime. Yeah. Yeah. No, you gotta use the require else simply because now you're saying set number is a descending class of command, so you must say require else. It's syntactic requirements. If you don't do it, it's going to complain, the compiler. Okay. Okay, guys, any questions? Yes.
So are we saying that if the standard class has a precondition, and so as long as we match the precondition of its ancestor?
As long as you match that or make it weaker, or make it more tolerant, that'll be okay.
Then we won't be running into a problem. Right?
Then we don't run into a problem.
What if we have, like, for example, if we have B inheriting from A
Yep.
and C inheriting from B?
The same. So basically, it keeps combining the precondition using conjunction. So disjunction. Let me give you one more example. How about that? Let me give you one more. Let's say we have something like this. Okay. This is a little bit contrived, but hopefully it will make sense. Let's say we got A here, and we got B here. Let's say we have a feature over here, which is going to take an integer. And then over here we say require I is larger than 0, which means in order to call this particular feature, let's say it's a command, it must be the case that I is strictly positive. Okay? Now, if I try the following, okay, so this, I try to redefine this, I'll say plus plus, redefine that, and then over here, I is of type integer. And then I would say require else. If I simply put I larger than or equal to 0. Okay, so let's think about, again, two issues here. Is it an appropriate design? And second thing is first of all, is it an appropriate design? Are you sure?
If it is 0, it won't satisfy the ancestor, right?
Well, I'm thinking this way. Let's say this is P1, and this is P2. In order to be appropriate design, we must have P1 implies P2. Don't you agree? Is this the case? I larger than 0 implies I larger than equal to 0, right? Yeah, that's good design. What about at the runtime? At the runtime, what's going to happen is, so this is design, right? About the design. Okay, so this is good. Okay, have a check mark. What about at the runtime? At the runtime, what exactly will be checked? Let's try. It's going to be this particular precondition, which is I larger than 0, or this one here, I larger than or equal to 0. We can simply do some simplification over here, right? Because this is simply includes all the possibility for this already. So that's simply equivalent to I larger than or equal to 0. Right? So it's going to work. Okay? That's better? Okay? Yeah. Go ahead. Let it be more tolerant.
So let the ancestors precondition fail. So that's
Not really to really let it fail. Yeah.
0, 0.
Yeah, I'm just trying to say, when you are trying to design a precondition for your subclass, it really depends on what you need. You're not supposed to make it require more. You should require less. Yeah. How much less is up to your design, right? Guys, are we okay? Yes, questions?
So just like last example,
Yeah.
when we use command, command is the top class, so we don't use require else. But what if I inherit from any?
If you simply inherit from any, okay, you mean over here? Okay, so now, okay, let me try to understand what you mean. So we still have this command class, right? We still have it?
I mean, there is any random class. It's the default one. It's not the default. It's a hit, but it's inherit from any.
Okay, so what classes are we talking about? Are you talking about command or other classes?
No, any other.
Any other class, okay. Okay. What class are you talking about? Let's say class, okay, let's see. Let's say we have a class A, and then, yes. Make it effective, okay.
And inherit from
Any? Sure. And then
should we use require else?
depends on which feature you're talking about. I see what you mean. I see what you mean. Let's try the following. Remember, any is just like an object class in Java, right? One of the feature that two features are actually declared over there. One is called is equal. The other one is called out. So is equals like an equals in Java. Out is like a toString in Java, right? So now, if you're trying to, let's say this is already got implementation there, so plus. If, let's say, for example, you want to say the out feature, it's kind of rare, but you can do it, right? If you simply say out, I would say require else. I will put something here. But I tell you what, this is not going to work, simply because in the out feature over here, there's no precondition, right? So if you want to make some precondition over there, you know what? This will, okay, let me make it clear. So guys, the question actually is quite important, okay? If you look at the class any over there, let's say we talk about the class called, the feature called out, okay? If you look at the out feature there is no precondition, right? So now, when there is no precondition, right? Now, let me ask you the following. It's actually in the slides. We're going to go over that, okay? I have two options for you. Let's say the out feature there has no require clause. Is it equivalent to out require else? Oh, sorry, require true, option number one, or is equivalent to out require false, one or two? You think that's one? Okay, any, you think it's one, right? That's intuitive, but that's not right. Think about what would be wrong with that. Yeah, exactly. You think it this way. If you declare no require on any of the feature at a parent level, you don't have a require. It is equivalent to basically this one here, require false. Simply because, let's think from two angles. If you, let's say tentatively, if this was the case, so that means whatever precondition you define over here, let's say P over here, it always has no effects because true or P is always just true. Doesn't matter what you put there. That just doesn't matter. On the other hand, if I choose this option over here, what does that mean? That means whatever precondition you add at the subclass level, it would be false or P, which is P. Right? That means if in the parent level I don't have any required clause, but now I do want to introduce some new precondition, it is okay. Okay. Yeah, we'll actually go over the slides on this. Huh? It's by default. But you should really know why the default value is like a false over there. Yeah. Questions? Okay, guys, any questions on this? Yes.
If the precondition for the parent level require out is false, doesn't it just pass condition out methodology, the out feature?
Yeah, because it simply say if you want to call the descendant objects over here, don't interpret too much. It simply means if I got over here out feature over here, I don't have any precondition over here. It simply means require false. And now if I try to introduce a new precondition at the descendant class, at the runtime you will simply check false or P, right? It's just going to give you the new precondition there. Okay. Okay, let's go a little bit more slides. Hopefully things will be clearer. Okay. Guys, the principle hasn't changed. At the runtime, you try to use disjunction for combining the precondition. You try to use this conjunction for combining the postcondition. Okay, at the runtime, it's always the case. Okay, actually that's exactly what you just mentioned. Okay, now let's have a look at this. So now, if you don't have any, let's see over here, require over here. Now, let's say over here, if you simply have, let me ask you this question here. Let's say we got foo and we got bar over here, right? So let's say foo is the parent class and bar is the subclass, okay? Now we do have a feature f, which got original precondition. It does have something over there. Okay, the same argument applies to this case. Simply means if we don't just have require, what does it really mean? Okay, in the subclass over there. So now if we say, so this will be as if we say require else false in the subclass over here. So why is that the case? If you simply don't, if you don't have it? Let's say this. Let's go back to our smartphone example over here. Okay, let's go back to this example here. Let's say this is the parent class, smartphone. Let's say we simply, sorry, highlight wrong thing. We keep this require over here, the blue one. We keep that one there, okay? And then now let's say in the subclass iPhone 6s Plus. For the moment, let's say we simply don't simply have this. We simply have no precondition over here. So what does that mean? Just no precondition. Yeah, that basically simply means we are going to inherit whatever the precondition we have from the parent class and use that as our precondition, right? But logically speaking, it is as if we said the following. It's as if we say over here, I'll put it here, require else. Now, give you choice over here. If I don't have anything over there, is it as if I say require else false or require else true? Which one? Similar argument, right? Because the consequence of having require else true would be we're going to combine this true value here and this particular precondition over here with this junction, which will be equivalent to true. What that means is now the descending class has no precondition whatsoever. That means any value can just work. But that's not right. Okay? When you have no precondition declared for the descending class, that simply means we're just going to inherit verbatim from the parent class. And to really have that effect, we must interpret that as require else false. Okay, guys, it's a little bit tricky. Okay? Yes. Yeah. Which one? Yeah. I see your point. I see your point. It's kind of the boundary case that we're talking about. I see what you mean. Okay, let's say this. Let's say we have our smartphone. Let me just make it clear over here. Well, yeah, let me just put it down. iPhone 6s Plus. Okay, let me just say this is a get reminders feature. Get reminders, and also this is get reminders. Okay, this is a plus plus. And then here, we simply say require the battery is larger than or equal to 0.1. Okay, let's get to discuss that. And then let's say over here I simply declare nothing. Okay, now what we said before to say to judge to see if that's good design or not, you should really see whatever you specify over here should be implying whatever that's specified over here, right? But we don't specify anything over there. So in this case, we don't have to judge any design decision here. It's always okay to leave that empty. Okay, so now design, is the design appropriate? Or not? Yes, because just no precondition. No precondition specified for the descendants. When there is no precondition specified, you don't have to do any implication proof. This is like a very extreme case. On the other hand, the second issue, which is what we are talking about over here, at the runtime, how would the runtime system treat this, right? When you actually specify nothing over here for the require, that simply means you want to inherit the precondition from the parent class. Okay? So now, at the runtime, how does the iPhone runtime treat this? Should it treat this as simply just true? Or should it simply treat this as false? That's the question we are talking about. right? Because we know whatever I have over here and whatever I have over here, I'm going to use a disjunction to combine that. So that means if I simply treat this as true, it's not going to have the effects I'm intend. So that's why it's going to be treated as false. Okay? At the runtime, okay, what we will have is b larger than or equal to 0.1 or false. So that will simply give us b larger than or equal to 0.1. Okay, that's what they will have. Okay, so only try to judge the design decision if you got precondition explicitly specified at both levels. Otherwise, you have to go with the default values, which you don't have to judge if that's a good design or not. Yeah. You'll be treated as true. Yes, correct. All right, guys, any more questions about this? Yeah, it's I know it's tricky, but try to think about it. Maybe in our exam review session, we can talk a little bit more, okay? Later, but let's just go over the slides quickly. Okay, the similar argument apply also to, let's say now, similar issue here. If I have the post condition specified for the parent class, but I have no post condition specified for the subclass, okay? In this case, again, we don't have to judge to see if that's good design or not. It's simply nothing specified there, so no need to judge. But now, what's going to happen at the runtime? Okay, the principle is whatever post condition it is going to combine with conjunction with some value at the descending class level. In this case, should that be false or true? True, right? Because if it's treated as false and something will just be false anyway. So that means you don't fail always. So that means you just be true. Okay? So that's the argument for that. So basically, this slide just tells you when you don't specify any require or ensure clause, there's some default values over there that will be evaluated at runtime. Okay? But you just need to know the rationale behind why we chose this value. Just has to do with the logical rule that you learned in 1019 or 1090. Okay. Let's go a little bit further. Now, let's go just a little bit more further over here. We're almost done with subcontracting, okay? Now, let's talk about invariance. Invariance basically is just like the post condition, right? Because invariance is like the post condition for every feature that you have in your class. Now, let's just see one example. This is a principle. Every class inherits invariance from all its ancestor classes, just like post condition. And the way we combine the invariance together is also by using conjunction. That should be no surprise to you, just like how we accumulate the post condition. Let's see the one example here. Let's say we have a class called polygon, okay? And the polygon simply got vertices, let's say an array of points, okay? And then here we say that for a shape to be polygon, the vertices that count should be larger than or equal to 3. Let's say, because if it's simply 2, it's just a line, it's not a polygon. Okay, with this invariant here? Okay, so now, how would I specify an invariance to say it's a rectangle? If you think about it. Yeah, okay, actually before I ask you that question, if I say the invariance over here, vertices that count larger than or equal to 3, that means when the vertices that count will be 3 or 4 or 5 or 6, all the numbers will be valid for this particular polygon, right? But now, if I simply say rectangle inherits from polygon, and I don't do anything to the invariance, it wouldn't be considered as appropriate. That means you're not really restricting about the number of vertices for the rectangle. So how would you do it? The way to do it would be, you would say something like this. You would say rectangle inherits polygon, and then you be more precise about what the vertices would be. You just simply 4. So now think about the implication over here. Let's say this is invariance number 1, and this is invariant number 2. Does invariant number 1 implies invariant number 2?
Yes.
Huh? Really? No, right? Okay. Invariance is pretty much like post condition. You want to make sure ensuring more, right? We know that this will be okay because the invariance over here, P2. P2 implies P1. over here, right? Agreed. Okay, to strengthen your understanding, so this would be just what's going to be checked. Whatever invariance you have over here in the parent class, conjunction with the invariance at the subclass level, right? So now a question for you. It's basically a design issue, design decision, okay? Can pentagon be a descendant class of rectangle? Well, intuitively, of course not, right? But how can you judge logically? You know what the pentagon is, right? Hopefully, right? Good. Yeah. 5? Okay, let's say this. Let's try to judge logically before I show you the answer, right? Let's try to do a little bit logical practice here. If I do have a pentagon that's inherited from rectangle, let's say I do that, okay? Now, how can I define the invariance for that? Good. Okay, if I say pentagon actually is a class where the invariance is vertices that count is equal to 5. Now, it's going to accumulate all the invariance from its parent class as well, which is rectangle. So now you want to say vertices that count equals 4 and vertices that count equals 5. What would that be? False. It cannot be equal to 2 values at the same time, right? So that is how you judge to see it's not appropriate. Okay, better? Okay. All that's said in this slide here is when you try to accumulate invariance, just like postcondition, use conjunction. Okay. All right. Yes, questions? Oh, good question. This one is easy, okay? You're asking if there's no invariant, let's say for your account class, okay? Account class, let's say we have the balance attributes, let's say only one attribute, and there's no invariance. If there's no invariance, does it really mean the invariance as if true or false? This one should be very intuitive. Why? Because if the invariance is false, the object will just crash anyway, right? The invariant has to be true by default, which means you have no restriction on what a safe state, safe state is. All right. Now, finally, let me just say to conclude. So at the design time, if the precondition and postcondition are explicitly specified, how do you judge to see if they're appropriate or not? So you got to check to see the parent precondition implies the child precondition, okay? Require less. And also, for the postcondition, you got to be ensuring more. That's what you judge to see statically. At the runtime, you have to know how we combine the values for the precondition and postcondition together, right? From the parent class. And you do the disjunction for precondition, you do the conjunction for postcondition. Okay? So it's more like a summary. Okay? Of course, the default values actually are derived from over there. Any questions? Yes.
Just to reiterate, if we don't put ensure, it's default is true.
If you don't put ensure, it's true. Yes. If you don't put require, it's going to be false. Right? Yeah. In case you forget, as long as you remember, it's going to be disjunction versus conjunction. You can easily work out backwards. Yeah. Okay, guys. Any questions before we move on to a new design pattern? Questions? We're okay, right? Good. Let's now go to this new design pattern. It's quite a big lecture here, so I will split it into 2 parts. Let's see how much we can do today. We'll continue for the rest on Tuesday. Okay? So it's going to be something about observer design pattern, but after we talk about observer, we also talk about something related to it, which is called event-driven design. Okay? But we'll talk about both at the end. Let's see a motivating problem over here. Let's say we have a weather station, the equipment's there on the left-hand side over there. Let's say we got the various apps you would like to support. Let's say whatever app you develop in 1022. So let's say let me just go over what the apps are supposed to, simple apps, okay? But all the apps are going to do their functionality based on the same weather station, weather data, okay? So let's say the weather station maintains the weather data such as a temperature, humidity, and pressure. Let's say these are the 3 data we focus on, okay? So now every app is going to use not necessarily all of them, maybe some of them, okay? For example, let's say we have a current conditions app. So what the current conditions will do is simply just going to display the temperature and humidity, let's say, very easy app, Just use 2 of them. So for a current conditions app, they don't care about the pressure. Okay. Now, second app, forecast. A very simple forecast. Let's say the forecast is going to tell you whether it's likely to rain. In order to see if there's going to rain, there's got to be some strict reduction on the pressure of the air pressure. Okay. So that means over here, it's expecting any rain due to reduced pressure. Okay, so that means it only cares about the pressure only. The third app is about statistics. So this one here is going to maintain the maximum, minimum, and average data for all the 3 data. Okay, so let's say it's going to tell you what's the maximum temperature so far, and what's the maximum humidity so far, and what's the maximum pressure so far, and also minimum and also average, right? So these 3 different apps over here, first of all, they observe different parts of the same data. And the second, you have to make sure every time you want it to display, they have to make sure they display the latest calculation. Okay? That's kind of the problem we are facing. Okay? Now, how do we solve this? Okay? Eventually, we're going to see 3 different versions for this problem over here. So the first version is just kind of intuitive, but we're going to tell you, we're going to criticize on that to see why we want to move a second version. The second version is so-called observer design pattern, which is a very reasonable solution already, which you can do in Java. But the third solution over there goes even further to improve the design. Okay? It's called event-driven design, which you can also do in Java, but not so conveniently. I'll also show you how you can do it in Java as well, and compare that solution with IFO. Okay, we got 3 versions there. Okay. Now let's have a look at the first solution. Okay, so we'll see quite much code today. Let's say the first solution over there. Let's try to understand this first design using architecture diagram. Okay, let me just switch to iPad over here. Let's see what the first solution is really about. Okay, it's not that complicated. Let's try to understand the architecture here. So we have a class called weather data, which is effective. Okay? And for the weather data, it has temperature, it has humidity, it has pressure. Okay? And then it also has a Boolean query over here to tell you what the legal limits are for each of the measure, right? And also the variance over here is, since we do have a variance, that tells us what the valid states for each weather data is. So we simply say correct limits and these. Okay? The exact value is not really the focus here. I'm just saying there's such a feature you have to define for the app. Maybe the temperature shouldn't be below minus 200, for example, right? Okay, that's about weather data, very easy. Okay? Now, let's have a look at over here. Question for you. When I have an arrow like this with weather data, what does that mean? Client supplier, okay. Does that mean I have a feature in forecast called weather data? What does that mean I have a feature called weather data in the weather data? Formal, right? Okay, make sure you got the direction right. Okay, good. That simply means in the forecast class, I simply got a feature weather data of this type over here. Okay, that's a client, that's a supplier. Okay. Similarly, current conditions app also got weather data. Statistics also got weather data. And then we have the display feature over here for each one of them. Each one of them. Of course, each one of them is going to display different parts of the measures. And then we also got, let me just show you something here. For the forecast over here, we only worry about the pressure level to see if it has been reduced. In which case we can say it's likely to rain. So that means we try to maintain 2 values there. One is called the current pressure. The other one is what's the last pressure I just read, right? Compare the 2, right? It's easy implementation. And for current conditions over here, I worry about the temperature and humidity. Okay, so these are the 2 I worry about. Just display them. For statistics, I need to worry about temperature only, just to see what's the average, what's the minimum, and what's the maximum. Okay, so far so good? There's one minor detail which is quite important, which I didn't show here just yet, but we'll see the code. Are you happy with comfortable with the architecture here? Very intuitive, right? But we're going to see some major drawback in just one moment. Okay, let me give you one little hint to keep in mind. After we have seen the code, I will ask you to criticize on this design. Think it this way. This weather data is going to be maintained by weather station, like here, the weather station. And then each one of the forecast, current conditions, and statistics, they are simply like a web-based or web-based app, which means every time if you want to get the latest reading, you have to connect to the web and get, to the server and get a value, right? That'll be a little hint to you. Okay, we'll get there. Let's see some code altogether. Let's see the code over here. Let's see for weather data, we simply got 3 attributes over here, and then we got correct limits. Let's say correct limits is simply just these values over here. Doesn't really matter the exact value. It depends on the application. And then we have the require for the constructor, which means if you want to create a valid copy of the weather data, you better make sure the correct limits is actually respected. And also, once you have created weather data, you want to make sure always is the correct limits. Okay, this part is rather straightforward for weather data. Okay, let's see how we can implement each of the forecast correct current condition and statistics. Let's see the first one. How do we do a forecast? We simply want to know what's the latest reading for the pressure and what's the last one. And if the current one is strictly less than the last one, it's likely to rain. Otherwise, it's not likely to rain. Okay? So what we can do is we can simply maintain, you can see weather data, right? That's why we got a client-supplier relation, as you can see from the diagram over here, right? Weather data over here. Right? And then we got current pressure, we got last pressure here. Okay? And then the most important thing I want you to see in the constructor over here, when I try to create a new forecast objects, I simply pass the link to the particular weather data I'm trying to observe, and then simply assign that to the weather data attributes. Okay, we'll see some runtime test. And then what about updates? So this update here is important. Okay, think about what the update is trying to do. I'm saying that in order for me to get the current pressure, what I'm saying is get to the weather data, which may not be in the same physical location as the app. It might be through some remote procedure call, which will take some network bandwidth for you to get the data. And then we say weather data dot pressure, and then save whatever it used to be the case before to be the last pressure. And then what display? Every time when I want to display whatever the prediction is, I want to make sure whatever value I'm trying to make my prediction on is the most up-to-date value. That's why every time before I try to display over here, I always try to update, right? That means I always have to connect to the server. Okay, keep that in mind. And then, so here simply just the prediction. If current pressure is larger than last pressure, that means it's not really going to rain. Otherwise, it's going to rain. Okay. Any question about this slide here? The important parts you really pay attention to are the one in yellow. First of all, we try to make a link to the weather data we are observing. And number 2, every time before you can display on the screen of the app, you have to update by connecting the server of the weather data. Okay? That's a critical thing to keep in mind. Similarly, I have something here as well. Let's say for the current conditions, I worry about only the temperature and humidity. And also I got an attribute weather data, right? Just like here, right? Also weather data over here, client supplier. And now I also assign weather data to be there for the constructor. And then for the updates, I just update 2 things. I update temperature for the weather data. I update the humidity for the weather data. Okay? And then display, what should I do first? Updates. Same as before. That's the most crucial thing to do. Making sure whatever you display on the screen for the app is the most up-to-date information. Okay, and then you do the rest. Now, statistics. I want to maintain the maximum, minimum, and average for the temperature. So how do I do that? So again, you got weather data attributes over here. Okay, as the previous 2 apps. And also, what's the current temperature? What's the maximum, minimum, and what's the summation so far? And what's the number of readings so far? Right? The logic there is not the important thing to note. Okay, again, we try to connect the weather data objects to the current statistics app, and then we try to say updates, And in this case, we only update the temperature. Okay, now, in order for me to do display, I also need to do updates, right? Same as before, okay? Okay, guys, any questions? Yes?
Is it A weather data not part of the weather data class?
Which one?
You know how it says A weather data? Highlighted?
A weather data?
Yeah.
You know what? It's a very good question. I think what I meant to say over there should be WD. Thank you. Yeah, I like the sharp eyes. That's good. Yeah, it should be WD. Yes, there's a typo. I'll change that. Yeah, so this weather data over here should be WD. Okay, so now let's try to see some code execution and see how things work at the runtime. And then we'll criticize on that, and then we'll move on to observers. Okay, I will just try to show you at one go on the iPad over here. Okay, let's see this. And then we'll see some runtime structure as well. So what I will do is, let's try here. So we declare current conditions, forecast, and statistics. We got 3 objects for the app. And also we got the weather data to be observed. Okay. Now, let's see this. First of all, we try to create WD weather data to be temperature, humidity, and pressure. Okay. So now WD is a weather data objects. It's going to be temperature, pressure, and humidity. Okay, just set it up. Very easy. The next line is going to be interesting. Okay, let's see one of them. Create cc.make. So we're talking about this particular object over here of type current conditions. Okay. When I do that, what do I do over there? If you remember, what we do is for the current conditions here, inside the constructor, I simply set the weather data to be whatever the argument is. In this case, it's simply just WD. That means for my weather data attributes over here, I'm going to link it to this particular objects. Make sense? One more thing to note. Whenever I say cc.weather data, the dot notation, it actually involved to actually connect to the network and get the data from the server. Okay, something to note. Okay. Now, what about this line here? So when I say create FD forecast.make, well, the same. FD is here, and then we connect this also to the same weather data, the same. Okay, similarly, what about create SD, the statistics? The same, SD is here, connect to the same weather objects. Okay, so far so good. Now let's try the following. Let's say the weather data is updated from the weather station. So what we will do is we execute the next line. Let me just highlight it in orange. Let's say I simply say over here, I set the measurements for the weather station for the weather data to be a new value. So what this will do is going to set to new value 15, 60, and 30.4. So what I will do is this will be updated to 15, and this will be 60, and this will be 30.4. That's from the weather data side, right? Now, if I try this particular line, blue line over here, right? I try to display on each of the app screen, right? What's going to happen? What's going to happen is, if you look at the display over here, for every feature, or for every app, the first step is simply just to updates, right? Remember, the updates over here, and the updates over here. That's from the previous decoration. So that means, in order for me to display for CC, I need to make a remote procedure call to here, and to get the latest value, and then try to make a current conditions updates. And then similarly for FD, I also have to make another call over here, and for SD, I also need to make a call over here. Okay, so far so good? Okay, now let's see another one. Let's say now periodically I want to refresh the screen for the 3 apps. So now let's talk about the green one over here. Do you think I'm going to get the same value after the updates? The question is, let me make it more clear. Specifically, if you look at cc.display over here versus CC.display over here. Am I going to display the same value on the screen? Yes, right? Simply because there was no change on the weather data like before between the two calls to the display. However, when I try to call CC.display for the second time, what does that mean? That means I'm actually still going to make a call to this particular weather object, and here as well for a separate time. Even though there's no updates on the server side, I'm still trying to make a request. I'm somehow wasting the resources for the bandwidth. See the point over here? Good. Okay. So now that means that will be the same. Now finally, let's see what's going to happen here. If I try this one over here, so say set the measurement to be 11, 19, and 90, and 20. So what this will do is new value over here. So 11, and then 90, and then 20. Right? New value. Now this time, when I try the final time over here to update the screen, let's say I use let's say pink color over here. Right? This time here, again, for every display over here, I'm going to also connect to the server and get the latest reading. But this time will be okay. It will be just required, right? So I'm going to make one more connection there. Okay, one more connection there, one more connection there, and one more connection there. So 3 connections in total. But the connection in green is unnecessary, right? But let's say this. If between the 2 updates on the weather data, if it's been a long time when there's no updates, but I will periodically connect to the server from the app. So I'm wasting the resources so much. Okay? Questions?
How can you explicit update if CC, FD, and SD, all their weather data already points to weather data? So if you just change weather data, won't it already show up?
Yeah, true. But the main point is, when you try to say, let me just go back to the code over here. The main point is, when you say, let me just point to you. Let's say for example here. Weather data, the temperature. Let's say this one here, right? Weather data is actually a remote object that you have to connect to using the web connection. And then, so really using an auxiliary attribute is not the issue over here. The issue is the link to the weather data over here is remote. That means every time you want to get this particular value for the temperature for the latest reading, you have to connect to it anyway. So there's no way around. Yeah. Okay. Okay, guys, any question about this design over here? Okay, criticism? Any criticism for this? Yeah. If I did a single choice principle, how? It has so many links? Not really, yeah. Well, guys, it's good that you think about design principle. Make sure you say that right, but that's okay, yeah. Nothing to do with single choice principle, okay? It's more about, actually, I already gave you the hints when I was trying to explain things, right? Yeah, basically, when I say resources are wasted, that means periodically, the apps are actually going to updates to the server, even though the updates are not so necessary, because there was simply no changes on the weather data. So that means it should be more efficient for this particular design to say rather than the apps to actually periodically request updates from the server, even when unnecessary. It should be the other way around. To say the weather data subject over there, they should really publish their updates to the apps rather than the other way. Okay? What I meant was, if you look at the diagram over here, and then we'll move on to observer pattern. If you look at the diagram here again, right? It's one directional. Whenever I want some update for forecast, I have to make an explicit remote procedure call to the weather data, even though it may be unnecessary. But a much better way to do it would be if I can somehow let weather data also maintain the links for the 3 objects over here, and then I will let the weather data do the updates only when necessary. Whenever I set a measurement for the weather data, I can let the weather data to publish the update to this app here over here, and also to this app over here, and also to this app over here. That's something we can improve. Okay, and that's the essence for observer pattern. Okay. Any question about the first design? First of all, why it is bad? It is bad because it's one directional, and you'll be inefficient at the runtime. Okay? All right. Okay, that's about the first design, and now we're going to, and that's exactly what I just mentioned. Okay? So now, to really avoid such overhead about connecting to the server, it would be better to do the following. First of all, each application, like a forecast, current conditions, and statistics, each one of them should be subscribed or attached or registered to the weather data, okay, somehow. And every time when the weather station has some updates on the weather data, they should publish or they should notify all the apps about such change. Okay? Only publish and notify when necessary, basically. Okay? And now, how do we see that? That's observer pattern. Okay? So now we are done with the first design. Let's see how we can improve this by introducing the observer pattern. Okay? Guys, any questions? Yeah, let me use 5 minutes to talk about observer, and then we'll continue next time. Okay, let me use 5 minutes. Without looking at the code, let's look at the bound diagram. Okay, I would say this one is not really similar to any of the patterns we learned before. Okay, but it's good to get exposed to new things. Okay, the pattern is called observer. Any one of you actually did observer pattern back in 2030? I wonder. No, right? That's good. So you're learning something new. Okay. Observer pattern. So this is a general pattern. After this slide, I'm going to tell you how you can instantiate observer pattern for the weather station problem. But we'll get there in just a moment. Okay. So now let's clarify some terminology. For the observer pattern, you actually got two concepts which should really reside on two different clusters. One is called subjects. The other one is called observers. Okay. Subjects are like the weather data. Observers are like the three apps that we talk about. So for subjects over here, it's a general class. You can have subject number 1, subject number 2 as descendant classes. You can have as many subjects as you like. And similarly for observer, you can have as many observer as you like. Okay, that's about the inheritance here. But we'll see inheritance in just a moment. Now, for the subjects, the most important thing you should really notice is here. There is an observer list. Okay, and now I want you to look at what's the static type for observer. What's the static type for observers? Observer. Okay, let's just make that note. Oops. So this is static type is simply observer. So what does that mean? That means at the runtime, this list is polymorphic. Each element can be either of the observer objects that's created from here, the descending classes, right? That's polymorphism that we talk about, okay? And then we got observers, and also we got a feature called notify. Notify simply means whenever there's an update to the subjects, like to the weather data, I want to notify all the observers at the moment about the updates, rather than observer requesting an update from me. It's a different direction, okay? So now you can see there's a contract over here. Let's try to understand that. What I'm trying to say over here is for every observer O, for every O that's in the observers, after the notify, they should be up to date with the subjects. But exactly how you define this up to date with the subject is up to your application. For example, the temperature and pressure should be up to date. Okay, let's see the observer class. For the observer class, you should really got something called updates, which means whenever the subject wants to publish the updates to every observer, what the subject will do is to call the update feature on every observer. It's a little bit like to call the undo feature on every command for your lab number 4. A little bit like that, okay? Okay, and then also you have to define in the observer what does it really mean to be up to date with the subjects. And this is simply deferred, because depending on what kind of observer you're talking about, if you're talking about current conditions, you have to make sure the temperature and humidity are up to date. If you're talking about forecast, the pressure should be up to date, right? Okay, just give me 2 minutes. Let's finish this diagram, and then we are done. Okay? Now, how do we apply the previous observer pattern to the weather station problem? Let's see quickly. what we can do is, over here, we still got subjects over here, we still got observers. So now we are being more specific about what the descending classes are. So subjects is before, observers are also is before. Now let's look at these two classes. Weather data, for example, is a descending class of subjects. That means weather data is being observed. And here we got temperature, we got humidity, we got pressure, and also we also got correct limits, right, as before. Okay, so nothing too exciting for the weather data part. Okay, now and also you got also forecast, you got current condition, also you got statistics. Okay, so these are the descending classes for the observer. Okay, now what's really interesting is about the bidirectional arrows over here. Okay, let's see. Over here you can see that we're going to define commands called attach and detach. It's more like a subscribe and unsubscribe. When you say I want to attach a particular observer to a subject, that means I want to add the observer, which can be either forecast, current condition, or statistics, to one of the observers for the current subjects. That's what that means for this direction over here. And then whenever I want to notify from the subject side about every observers about the updates, what I should do is I should go to every observers in over here and then try to call their update feature. When I try to go call the update feature, how can each observer get the updates? They have to follow this particular link for the weather data. Okay, guys, are we okay? Okay, so we are running out of time, right? Okay, so try to review this diagram here. For the projects, notice that you only got less than 3 weeks left. Okay, make sure. I'm gonna remind you every day. Okay, see you later.